All right, guys, this is actually graphing sine and cosine. This is 11-7 part 1. Okay, so in 11-6 we talked about circular motion, and I have a goal here. Let me set my timer, and you guys can fast forward past this part because I'm setting my timer. I have a goal to get this done in under 15 minutes. I don't know if it's possible. It's a lot of information, but we'll see what happens. Okay, so if you want to stop it, I would stop and write this information down because I'm going to explain it to you guys here real quick. So I'd stop it. We're going to go over the main points of sine and cosine, and then we're going to use the information to what's called the amplitude, and the amplitude is the height. Okay, and that is for max and mins. Max and maximums and minimums. And then the period is going to be actually 360 over b, or it's going to be 2 pi over b. So those are the two formulas that we're going to be working with, and I'll talk about that here in a second. So if we look at sine and cosine, I want you guys to kind of realize, you don't have to write this in the middle, but I'm going to kind of go through it real quick. If we look at the unit circle and we start at 0, we'll just start at 0 degrees. We know that the x and y is sine and cosine. Sine is 0, cosine is 0, sine is y. So if we look at this, I'm going to go around in a circle. So if you want to get your unit circle out, you can follow. I'm going to go a quarter of a turn each time. I'm going to go up to here, and that's 90 degrees. At 90 degrees, if you look at the y value, it's 1. Then I'm going to go to 180. If I go from 180, if you look at the y value on the unit circle at 180, it's 0. It's also the same spot as pi, so you can see it as 180, or you can have it in radians as pi. So you can either use these or these. The book uses both, so be ready. Then I go another quarter of a turn, and down here is 270 degrees, or in radians it's 3 pi over 2, so then I get a -1 value. And then 360 or 2 pi, if you look at the y value on the unit circle, you get 0. Now if we move over to cosine, same thing starts, but we're only going to use the x value. And that's where everybody gets messed up. Remember, for these graphs, the x-axis is radians or degrees, and the y-axis is the value of cosine at those degrees. So if I go to 0, cosine is 1. If I go to 90 degrees and I look at my point, it's at 0 and 1. 90 degrees, my cosine of theta is 0. If I go to 180 or pi, what did I do here? 1, 0. Oh yeah, -1. That's -1. It's -1. And then if I go down to 270 or 3 pi over 2, if I look at my cosine, my first value is 0. And if I go all the way back to 2 pi or 360, I'm back at 1 again. So it completes one cycle for cosine of theta. We have our x-axis and our y-axis. And the same thing here. This is our x-axis, and this is our y-axis. Okay? So that's how we come up with these points. We're using the unit circle. Radians and degrees are the x-axis. Sine of theta comes from the y values on the unit circle. Degrees and radians is the same. The difference is the y-axis, I'm using the cosine of theta around the unit circle. Okay? So that's where those values come from. So let's put some information on here. All right, so let's kind of look at this. So let's just graph it. I'll do it in green since I'm in green. So I've got a 0 here. At 0, remember this is in radians or degrees, and this is sine of theta. So at 0, the sine of theta is 0. At 90, the sine of theta is 1. So I'm going to put 90 degrees right here. Sine of theta is 1. At 180, the sine of theta is 0. At 270, it is -1. At 360, it is 0. And then I draw my graph. Remember, circular motions create waves. Okay? So if we talk to the sun is here, the sun is at its highest, it's back to the middle, the sun is at its lowest, the sun is back to here, from what we talked about last Thursday. So this here is my A. That's my amplitude. So my A, which is my amplitude, is equal to 1. The period is equal to 360 degrees because it's 360 degrees long. So the period's 360 degrees. Now, when we look at this, I also have a few pieces of information I can grab from this. I know my x-intercepts are here in red. So my x-intercept is here at 0 and 0. And then I know my x-intercept is here, and that's going to be 1/2 the period and 0. That comes into play in a minute. And then my x-intercept here is going to be the period and 0. Okay? So those are pieces of information we need. Now let's come over here to cosine. So if I take cosine, do the same thing. At 0, it's 1. At 90, or actually I'll do pi over 2 on this one. At pi over 2, it's 0. So now I'm in radians. And this is cosine of theta on the y-axis from the unit circle. Remember, cosine of theta comes from the unit circle. And then if I go to pi, I'm down at -1. If I go back to 3 pi over 2, I'm at 0. And then finally, I go back to 2 pi, and I am at, excuse me, I am at 1. And again, it makes a wave. This time it started in the summertime, it's at its highest, back to fall, down to winter, back to spring, back to summer. Okay? So we've got this thing here going. My amplitude, the height, my height, which is A, that's my amplitude, is equal to 1. The period is the length it takes to complete one cycle. So the period is equal to 2 pi. So these have a period of either 2 pi or 360 degrees when they're in their basic form. So if we look at this, here's my x-axis, or x-intercept. So my x-intercept is at 1/4 of the period and 0. And my other one is right here, and that's at 3/4 of the period and 0. Okay? So, lots of information here. We're going to work with these quite a bit, so I'm going to go ahead and erase this and leave this stuff up here. Pay attention to where these things come from, and then we'll work with them in a little bit. All right, so that's your basic information. All right, so I'm going to erase this, and I will stick with the colors here, and I will talk about graphing y equals 2 sine of theta. Okay, so we got to pull some information out of here. Now, this one doesn't have a b right here, so there's an imaginary 1 right there, okay? So let's pull some information out because we need it. So A, which is my amplitude, is equal to 2. So now my height's 2, it's no longer 1. My height, it's my maximum and my minimum. Now I have B here, B is 1, but I use B to find my new period, so I'm going to use 360. So my new period is 360 divided by 1. So that doesn't change anything, so it's 360 degrees. So now all we do is use this to graph. So let me put my axes up here. Don't forget, this is in radians. This is the sine of theta. So we follow the 5 main points before. At 0, it's 0, doesn't change. But at pi over 2, or 90 degrees, right? At 90 degrees, it's all the way at 2, because my height is now 2. So I'm up here at 2. And this is going to be -1 and -2. So when I go back down to 180, that's one of my x-intercepts. My x-intercept is half of the period. Well, half of the period is 360, so I've got one there. Then I go to 270, and I'm down at -2, and then I'm finally finished at 360, because the length of this is 360, and I have my graph. Okay? Based on the period, cut it into 4 chunks. Amplitude is your height, so this is A, whoops, that's 2, and that's 2 also. And then the period is 360 divided by 1. All right, so let's look at the cosine one here. Let's pull some information out of this cosine one. So we're going to do y equals cosine of 4 theta, I think is what they do in the book. Yes. All right, so now I've got my imaginary 1 for the amplitude. A is the amplitude, which is equal to 1. B is now 4, which now this changes my x-axis. I'll write that here in a second. Because now my period is equal to 360 degrees divided by 4. So if we do 360 degrees divided by 4, I get 90 degrees. So now this thing is no longer 360 degrees long. It shrunk it. So let's look at this again. This is my radians or degrees. Oh, that should have been degrees. I put it in degrees. That's in degrees, guys. This is degrees. Okay, this is my cosine of theta. So now this thing is, it starts at 0 like always, but now we shrunk it up, which it goes to 90 degrees now. So if you go back and look at the back notes, my x-intercepts are at 1/4 of 90. So my x-intercept is 1/4 times 90. And my other x-intercept is 3/4 times 90. So if we do the math on those, we get 22.5 degrees, and we get, this is 45 right here because it's half of it. We get 22.5, 67.5 degrees. Okay, so if you multiply 0.7 times, 0.75 times 90, or 3/4 of 90, my x-intercepts are going to be here and here. Now we just got to decide, what's my height? Well, my height is still 1, so I'm only going up to 1, and I'm going up to 1, down to -1. So I start up here, curve, down, up, and then to the top here. Okay? So that's how we pull the information out to graph those. Now, that you just kind of, so the only thing the amplitude's going to change is the height or the y-axis. So the amplitude, this changes the y, changes the y-axis. And the B here changes the x-axis. So make a note of that. B changes the x-axis, either shrinks it or enlarges it, and A changes the y-axis. It either makes it taller or shorter. All right, so here's our last piece of information. So we're going to do an example out of the book. I'll put it on the notes for you right about now. And that way, oh, there's 15 minutes. It didn't make it. It was pretty close. So here's our last piece of information, guys. I told you it was going to be tough to make that part. All right, so I'm using the example out of the book, which is example 3. And so they give us some information. I'm not going to write it all up here. They give us something about hertz. They give us 5 hertz. And they tell us that hertz is cycles per second. So basically what they're telling us is this, that this has 5 cycles per second. That's what hertz means. So if we're looking to find the definition of a period, it's how many times one cycle happens. So a basic definition is time over cycles. Oops, better write that better. Cycles. Wow. Cycles. What's my time? It's 1 second. Whoops. I can't write today. 1 second. And then how many cycles? 5. So my period is actually 1/5. Okay? So my period is actually equal to 1/5. So are we okay from there? All right, so hopefully, because I can't answer it over the internet. So I need to write this thing. So they wanted to know the period, so it's 1/5. Now, what they ask us to do from there is they ask us to find an equation. So let's just look at this here. So they need us to find an equation and a sine equation. So if we look at the sine graph, A sine B of theta. Okay? They ask us a couple of things. Number one, they tell us the amplitude is 1. So now I know that I have y equals 1 sine of something here. We don't know what this is. And they ask us, I believe, to put it in time. So they ask us to change theta to time. So they ask in terms of t time. That's where the t comes from. All right, so, but what's b? Well, we don't know, and how do we find out? Well, we know from this formula that the period, I'll do it over here so we can put it right in this spot. So the period, so this is t, the period is equal to we'll use 2 pi, they use 2 pi, 2 pi over b, the absolute value of b. So what is the period? The period is 1/5. We already figured that one out using hertz. 2 pi over b. So now what we've done is we've created a ratio. B times 1 is b. 5 times 2 is 10 pi. That's my b. 10 pi. That's my equation of the sine graph. Y equals 1 times the sine of 10 pi t. So these will probably be the harder ones that you can do. You can check out, I'll put 2 answers up there. You can check out and try 3A and 3B. So we have guided practice. You can do the guided practices if you'd like. And I would do the guided practices for 1A, 1B. I do all the way through 3. So guided practices 1 through 3. These are extra practices. You don't have to do them. And then I'll put the answers on there. That's it, guys. Hopefully I made it in a decent amount of time. That was a lot of information. Good job.